Good morning students, welcome to our online video class of chemistry. In this video we will discuss about Heisenberg uncertainty principle, de Broglie wave equation and quantum numbers. We have studied that light or radiation possess dual nature. Experimental phenomena like diffraction and interference typically project out the wave character of radiation, and the phenomena of photoelectric effect clearly establish its particle nature. Therefore, light has dual nature, possessing the properties of both wave and particle. And thus we are going to discuss about the topic the de Broglie hypothesis and wave particle of duality. De Broglie equation or dual nature of particle. In 1924, Louis de Broglie, a French physicist, suggested that matter particles in motion should also show the wave character. Then, according to de Broglie, just as light displays wave particle duality, matter also shows wave-like property in addition to particle characteristics. This is refers to as wave particle duality of matter. And de Broglie proposed the name matter waves for the waves produced by moving particles. De Broglie gave a quantitative meaning to his idea by proposing an equation which relates the wave properties of matter to particle properties. This is known as de Broglie equation. According to de Broglie, the wavelength lambda associated with a particle of mass m moving with the velocity v is given by the relation lambda equals h by mv. We know that mass into velocity, product of mass and velocity is momentum. We can represent momentum by p. So the equation become lambda equals h by p, where lambda is the wavelength, h is the Planck's constant, p is the momentum. Heisenberg uncertainty principle. Heisenberg in 1927 pointed out that we cannot measure accurately both the position and velocity of a particle as small as electrons. And he stated that it was impossible to determine simultaneously the exact position and exact momentum or velocity of an electron. Mathematically, the uncertainty principle may be expressed as delta x into delta p greater than or equal to h by 4 pi, or delta x into delta mv greater than or equal to h by 4 pi, because delta p is momentum, that is mass into velocity. Or we can write this equation as delta x into delta v greater than or equal to h by 4 pi. Therefore, one significant consequence of the uncertainty principle is its impact on Bohr's atomic theory. We have studied that according to Bohr atomic model, the electrons are revolving around the nucleus within a fixed definite orbit. That means both the position and momentum of an electron in any orbit at any instant could be known with a certainty. This possibility was completely ruled out by the uncertainty principle, and it is suggested that Bohr concept of well-defined orbit could not be correct. Next topic is orbital. What is called an orbital? An orbital may be defined as the region of space around the nucleus where the probability of finding the electron is maximum, and each orbital has a definite amount of energy. What is called an orbital? An orbital is the region in space around the nucleus where there is maximum probability of finding an electron having a specific energy. Difference between an orbit and an orbital. Orbit is a well-defined circular path followed by the revolving electron around the nucleus. An orbital is a region of space around the nucleus of an atom where there is a high probability of finding an electron. Orbit represents planar motion of an electron. Orbital represents three-dimensional motion of an electron around the nucleus. The maximum number of electrons in an orbit is 2n square. An orbital cannot accommodate more than 2 electrons. Orbits can circular in shape. Orbitals have different shapes. For an example, s orbital are spherical in shape. P orbital are dumbbell shaped. And the concept of well-defined orbits is against Heisenberg uncertainty principle. The concept of orbital is in accordance with the Heisenberg uncertainty principle. Next topic is quantum numbers. The set of numbers used to describe the position and energy of the electron in an atom are called quantum numbers. There are 4 sets of quantum numbers. What is quantum number? Quantum number is set of numbers used to describe the position and energy of an electron in an atom. The 4 types of quantum numbers are principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Let us study one by one in detail. Principal quantum number. This quantum number represents the main energy level or shell in which the electron is present. And it also determines the average distance of the orbital or electron from the nucleus. It is denoted by small letter n. It is denoted by letter n. And this quantum number tells us in which principal energy level the electrons is present. It can have only whole number value such as 1, 2, 3, 4 corresponding to K shell, L shell, M shell and N shell. As the value of n increases, the electrons gets further away from the nucleus. Principal quantum number also determines the size of the orbital. It's the main energy level or shell in which the electron is present. If n equal 1, that is corresponds to K shell. And if n equal 2, it corresponds to L shell. If n equal 3, it corresponds to M shell. And if n equal 4, it corresponds to N shell. And what is the next point? It also helps to determine the distance of orbit or electron from the nucleus. As the value of n increases, that is, the energy level gets farther away from the nucleus. That is, the n equal 1 represents the energy level nearest to the nucleus. The n equal 2, the next energy level further away from the nucleus. And n equal 3, that is next energy level further away from the nucleus, and so on. n can have any integral value from 1 to infinity. The energy level 1, 2, 3, 4, 5, 6, etc. are also designated. And what is the maximum number of electrons in a shell? The maximum number of electrons which a shell can accommodate is 2n square. Then the maximum number of electrons which can accommodate in K shell, which is equal 2 into n square, n equal. Then the maximum number of electrons which can accommodate in K shell, which is equal, here n equal 1, 2 into 1 square, which is equal 2. Then maximum number of electrons which can accommodate in L shell, n equals 2. 2 into 2 square, which is equal 2 into 4, which is equal to 8. Then M shell, n equals 3. Then 2 into n square equal 2 into 3 square, which is equal 2 into 9, which is equal 18. Then n shell, n equal 4. 2 into 4 square, which is equal 2 into 16 equals 32. The maximum number of electrons which can accommodate in K shell equal 2 and L shell equal 8, M shell equal 18 and N shell equal 32.
Momentum quantum number or Smith quantum number. This quantum number determines the angular momentum of the electron and it is denoted by L. The value of L gives the subshell or sublevel in which the electron is located. It also determines the shape of the orbital in which the electron is located. L may have all possible whole number values from 0 to n minus 1. The various subshells are designated as S, P, D, F depending upon the value of L.
What is a subshell? Electrons in each energy level are arranged in its sub-energy levels. Each sub-energy level in a shell is called subshell. They are named as S, P, D and F. For n equals 1, L can have only one value, that is 0. Thus the first main energy level or shell consists for only one subshell, that is 1s or 1s orbital. Thus the electrons belonging to the first energy level can be present only in 1s subshell. For n equal 2, the possible value of L are 0 and 1. Thus the second main energy level has two subshells, that is 2s and 2p. And for n equals 3, L can have three possible values, that is 0, 1 and 2. Thus the third main energy level has three subshells, that is 3s, 3p and 3d. And for n equal 4, L can have four possible values, that is 0, 1, 2, and 3. And the fourth main energy level has 4 subshells, that is 4s, 4p, 4d, and 4f.
Magnetic quantum number. This quantum number is denoted by m. It represents the different orientation of electron cloud in a particular subshell. These different orientation are called orbitals. Magnetic quantum number represents the number of orbitals present in the subshell. The possible value of m ranges from plus L to minus L, including 0 or m can have 2L. What is magnetic quantum number? It is denoted by m and it represents the orientation, different orientation of electron cloud in particular subshell. And this orientation are called orbitals. And the number of orbitals in each subshell are given as for L equal 0. M can have only one value, that is m equals 0. It implies that a subshell has only one orbital. For L equal 1, m can have 3 values, that is m equals minus 1, 0, plus 1. It implies that P subshell has 3 orbitals. For L equal 2, m can have 5 values, m equals minus 2, minus 1, 0, plus 1, plus 2. It implies that D subshell has 5 orbitals. For L equal 3, m can have 7 values, that is m equals minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. It implies that F subshell has 7 orbitals. Spin quantum number. It tells us about the direction of spin of the electron, that is anti-clockwise or clockwise. The spin quantum number can have only 2 values, that is plus half and minus half. The value plus half indicates clockwise spin and the value negative half indicates the anti-clockwise spin.